So here we go. Today, I broke 1-4 into two parts. I wanted to focus on recursive because I didn't have a lot of class time today. It was a quiz day. I discovered from first period that most people have no idea what arithmetic is. So arithmetic is nothing more than adding or subtracting. That's all it is. It does not include multiplication and division. It's just adding and subtracting. An arithmetic sequence is simply a sequence that moves from term to term through addition or subtraction. That's all an arithmetic sequence is. That's all it is. So an example might be something like 2, 4. You can probably tell me the next term now. It's 6, followed by 8, so forth. We had a common difference of 2. Another example, we might do subtraction. We might do like 3, 1, negative 1. Here we had a common difference, not of 2, but of negative 2, because we were taking away 2 as we move from left to right. An arithmetic series is simply the addition of terms within an arithmetic sequence. You can say arithmetic sequence, I just like to say arithmetic. I don't think it matters. It's tomato, tomato. So up here I might have done 2 plus 4 plus 6 plus 8, which is 20, right? That would be a series where we actually do some addition. You know, tomorrow we'll expand on this. We'll do things like sigma notation, explicit formulas, and today we're learning recursive trains of thoughts. So recursive is a thought pattern that's built upon knowing previous terms. That's what it means to be recursive. It's just a thought pattern of knowing previous terms and a simple pattern to find the next term or the next thing. Most thought that we do is actually recursive. It's how we're kind of hardwired to think. We don't think of how to come up with answers immediately. It's always a step-by-step process. So we don't have what's called the explicit way of doing things built into us. It's something we learn. Explicit means shortcuts, and tomorrow is shortcuts. Okay, today is recursive. And you'll see tomorrow. All right, format of the recursive rule for an arithmetic sequence. It's going to look kind of funny. I teach these as what we call piecewise functions. We have a giant ace of n, a big old curly brace, and the first term, which is called ace of 1, if n is 1. And then this funny looking ace of n minus 1 thing, if n is bigger than 1. So there's lots of little pieces here that you need to know what they are. Like what is ace of 1? And by the way, it's pronounced ace of 1. It is not pronounced A1. A1 is steak sauce. And with the economy the way it is, I haven't bought a bottle of A1 in a couple years. We buy the Great Value or the Clover Valley from Dollar General. But anyways, A1 simply means the first term in a sequence. Now, when you talk about ace of n is usually the term you're trying to find. It would be the next term, okay? Or maybe the current term, because usually it's the term you're after. And then you have that funny ace of n minus 1. And I always tell kids it means the previous term or the term before, but it's the previous term. And I left something off the rule. I sure did. I need plus D. And what does D stand for? D stands for the common difference of the arithmetic sequence. All right, there we go. There's the format for a recursive rule. All right, so let's write a recursive rule for this. And that's got a typo in it. That should say sequence. I made these notes up just before class day because I didn't like the notes I had. So we're going to write a recursive rule for this sequence, and we're just going to identify some parts here. The first term, which we call ace of 1, is negative 5. The difference between the terms is to add 15. And the previous term is always called ace of n minus 1. That's just what she's called. So here's our rule that the nth term is the first term, which is -5, if we are at position 1. From then on, we take the previous term and we add 15 if n is bigger than 1. And that's what we call a rule. Now, we can use that rule to find other pieces, all right, which is what the next slide's about. Write out the first 5 terms of the recursive sequence given by the following rule. So kick in your line-up process. This is the first term. That should be a 1. And this would obviously be the difference. We're taking away 1. So our first term is simply 7. The next term is to take the previous term and take away 1. So it would be 7 minus 1, which is 6. The third term is going to be the previous term of 6, take away 1, which is 5. And by now you should have established a pattern. We're losing 1. So the next one's 4. And the fifth term, which is what they said, first 5 terms, is going to be 3. Easy peasy lemon squeezy. All right, find the sum of the first 10 terms given by the rule. So we're finding a sum, we're actually doing what's called a series. Okay, so we're going to have to write out 10 terms. Remember, this is the first term, that's supposed to be a 1. So the first term is 2. The second term says take the previous term and add 3. It's 2 plus 3, which is 5. And that, by the way, is the common difference. We're going to add 3. You know, I'll write it out one more time on this one, but the previous term is 5. We add 3, we're sitting at 8. And then we just go through the process here. We add 3, we get 11. We add 3, we get 14. We add 3, we get 17. We add 3, we get 20. We add 3, we get 23. We add 3, we get 26. And we add 3 more, and we get 30. Now, this said find the sum, okay? So I'm supposed to add all these things together, right? And it's going to take a while, but I've done this one in class. Now I'll use some funny notation here. I'm going to put S of 10. This means the sum of 10 things. And the sum of those 10 things happens to be 155. Moving forward, almost done. Short notes today. The theater has 12 seats in the top row. Each successive row has 3 more seats. Write a recursive rule for this sequence. So the nth row would be 12 if n is equal to 1. We're on the first row, okay? And it would be a sub n minus 1 plus 3 if the row number is greater than 1. And there's the rule. They're not hard to write. All right, how many rows of seats are there if the bottom row has 36 seats? So in class we did this and everybody just wrote it out, which is wonderful. That's the whole point today, to understand that recursiveness means you write it out, and it's pretty easy to get it right. So the first row would be 12. The second row is 12 plus 3. Remember, we take the previous one, we add 3, and it's 15. The third row would be 18. The fourth row would be 21. The fifth row would be 24. The sixth row would be 27. The seventh row would be 28. The eighth row would be 30. I've made a mistake somewhere apparently. It's right there. I said that the seventh row was 28. It's not, it's 30. The eighth row is 33. And finally, the ninth row is 36. So there are 9 rows. It's not hard, it's just tedious, I guess. All right, Billy Bob realizes he is kind of fat. He decides to start doing push-ups daily. On day 1, he can do only 7 push-ups. Instead of feeling defeated, he decides that he will do 1 more push-up every day than he could the previous day. So every day he's going to add a push-up. Like day 2, he's going to do 8. Day 3, he's going to do 9. Day 4, he's going to do 10. He did a very realistic goal there. Now, he will not be able to keep that up indefinitely, but he'll be able to keep it up for quite a while. Write a recursive model. All right, so the very first day Billy Bob does push-ups, he does 7 push-ups. So that's if n, which is the day count, is 1. From then on, he takes the previous day and he adds 1 push-up. Now, Some kids try to figure out how to do this without writing everything down. That is an acquired skill. You'll get there eventually. Most of you will. But for today, we're thinking recursively. So how many days until Billy can do 30 push-ups? Well, we start with 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And it's easy to write. It is. We're just writing until we hit 30, right? And then we count. And if we count, we'll discover that we have 24 things. So 24 days, and he'll be able to do 30 push-ups, which is a pretty good number for your average Joe. So if you're an athlete watching this, you're like 30 push-ups. You find any random dude on the street, and they'll be lucky to get 10. Lucky. Like, kids talk about bench pressing 200 pounds, and some kids are like, well, that's nothing. Bench pressing 200 puts you in the top 99 percentile of all men. So, Billy's doing wonderful. I promise you, he's doing great, especially since he's kind of fat. Big difference between a skinny person doing a push-up and a big boy doing a push-up. Big boy working harder. Big boy pushing up more. Big boy stronger. Anywho, there's just a little rant. I'm pro Billy. You get in shape, Billy. On this day, whatever it may be, how many total push-ups has Billy done? So we are taking his first day of 7 all the way to his last day of 30, and we are adding them together. And it turns out that Billy has done 444 push-ups on his quest to fitness. And if Billy keeps that up, in a couple of months, he'll be in great shape. Push-ups are one of the best things you can actually do because of the balance that's done. There's a lot of auxiliary muscles that are used in keeping form. And it really is one of the best things you can do to get you in shape. So anyways, there you go. That is 1-4. I hope you enjoyed it. You probably did not. I mean, who wants to watch a math video? Maybe you're that kid. If you are that kid, you're probably kind of weird. Probably going to become a math teacher. Later.